A for loop is used for iterating over sequence objects like lists, tuples, or strings. I'm going to create a list here called fruit with the following items. We're gonna have apple, and then banana, and lastly cherry. Then I'm gonna iterate over this list using a for loop statement. Here's how you create a for loop statement. You have to terminate it with a colon mark. Then for each iteration, this program will execute a print statement. I have then whatever fruit is currently being processed here. So here, for each iteration, whatever it is in the body will be processed. By the way, this x variable here is just some random name. You could choose any name you want as long as it adheres to the naming rules as discussed in the previous videos. Let's run our program now. For the first iteration, the x variable will contain the value apple. Since that's the first item on our list, it will print out I have apple. That completes the first iteration. Afterwards, the loop will start its second iteration with x variable getting the value of banana this time. It will print out I have banana. And lastly, for the third iteration, x here will have the value of cherry and will print out I have cherry. At this point, our for loop will now end since there are no more items to iterate over to. Aside from lists, you can also iterate over a string. Since they contain a sequence of characters, strings are iterable objects. For example, let's iterate over the string cherry. And then we're just gonna comment out this line of code, so this won't affect our program in any way. And then we'll just print the x variable. For example, here we are to loop through the letters in the word cherry. Every character in our string will have its own iteration. For each iteration, this one's going to print the current character being processed. On our example, the first iteration would be the character C. Second iteration would be H. Third would be the character E, and so on. Let's check how this would look like. You can see that it printed each characters on our string in separate lines. We have a choice to not go over the whole sequence we're processing. We can do that by using the break statement. For instance, we want to iterate over this list, but we want to terminate the loop once we encounter the item banana. What we're going to do is to insert an if statement here. So let's do that. If x is equal to banana, and then let's add our break statement here. So what's gonna happen here is if the current iteration is processing the item banana, it will execute the break statement, effectively ending our loop. Then let's just add in another print statement here at the outside of our for loop. So end of loop. Okay, so here after the break statement is issued, it's no longer continuing with the for loop statement. That means all succeeding items will no longer be processed. In addition, on our for loop block, all statements after this break will no longer be executed. Here, once break is executed, this print statement will be skipped, ending the current iteration prematurely. But this print after the loop statement or loop block will still be executed since this one's outside of the for loop block. Let's run our program now. It only printed out I have apple since the next item on the list was banana. Afterwards, it still proceeded on printing out end of for loop. So here, this print statement was still executed. We can also skip iterating over a specific sequence without breaking the for loop using the continue statement. For example, we just want to skip the item banana but still iterate through the rest of the list. So meaning we still want to print out the item cherry. We'll replace this break statement here with continue statement. Let's test the output. This time, aside from apple, our program was able to iterate through the next item, which is cherry, while banana was still skipped. While loops repeat as long as a certain condition is true. For example, I'll create a variable named count and assign it a value of 0. Then I'll create the while statement, count is less than 5. Then our terminator here. Then let's add in a print statement. And then let's add this as well. So here, what's gonna happen is that while our count variable is less than 5, it's going to execute all these statements inside our while block. For each iteration, we'll add 1 to our count variable. By the way, this operator here, this one, is just a short way of writing count is equal to count plus 1. Okay, I'll just revert that. And then let's check the output. So our program printed out the numbers 0 to 4. Once our count variable reached 5, our while loop terminates. We can also add an else statement so we can run a block of code once the condition in our while loop is no longer true. Let's add an else statement here, and then on our else block we're gonna execute count is no longer less than 5. Here it will print out something, this one, when our count variable is no longer less than 5. Let's run our program again. So we can see immediately after the last iteration, which is 4, a print statement was executed immediately. Count is no longer less than 5. Similarly, with for loops, we can also terminate while loops prematurely or skip a sequence by using break and continue statements. A dictionary is another collection data type similar to lists, but instead of indexes, it works with keys and values. For example, a database of phone numbers could be stored using a dictionary like this. Let's add phone book, and then on our phone book, we'll add an entry for John, and then his phone number. Here, John will be the key, then the value is his number. Let's add more entries to our dictionary. Let's add Jack's phone number here. And then lastly, let's have Jill in our phone book. And then lastly, we'll print our dictionary. Let's run this program. Here it printed out all three items from our dictionary. So John, Jack, Jill. Each item consisting of key and value pairs. To access an item's value in a dictionary, you need to refer to it by its key name, inside square brackets. For example, if I want to access Jack's number, I will do something like this. I will reference it by the key name, which is Jack, and then we'll see how this turns out. And it printed out the value assigned to the key Jack, which is this number. To change the value of an item, we also need to refer to its key name. Let's try changing Jack's number by just modifying the last digit. Let's add an assignment here just before our print statement. And then let's copy this number. We'll just change the last digit and then run our program again. And it printed out a new number with the last digit changing from 4 to 3. To add an item to our dictionary, we need to use a new key and assign a value to it. For example, I want to add an entry for James in our phone book. So I'm just gonna reference him here, assign him some random number. So here, since James is not yet existing in our dictionary, he will be added to it. Let's run this again. But before that, I'm just gonna remove this one. And let's run this one. With the addition of the key James, we now have 4 items in our phone book dictionary. If we want to delete an item, we can use the pop method and specify the key of the item we want to delete. So let's delete James from our list. To do that, let's reference phone book and then use the pop method, then make a reference to James. So let's run this one. So we're back to 3 items after removing James. Just like this, dictionaries can be iterated over. To iterate over key value pairs, we'll use the following syntax. We're gonna add for statement here, declare our variables, then our dictionary, and we'll use the items method. I'll explain that one later. And then let's print something inside our for loop. Phone number of %s is %d. Then don't worry, I'll explain this one later. Let's just complete this one. Alright, so here in our for loop statement, we're declaring these 2 variables, name and number, to store the key value pairs for each iteration. You could also name them anything. I just happen to choose a descriptive variable name. Then we use the items method to loop through the both keys and values. And we've added print statement here. So for each iteration, our loop is going to print out the key and value pair. You've probably noticed that I use a new syntax here on our print statement. On the right side of our string here, this one, we're specifying the variables that we want to appear on our print statement. The % character here in the middle separates the variable list from the string. These variables then will be referenced by %s and %d. The ordering here on the right side is important since they will appear in the same order when you reference them in your string. On our example, %s here is referencing the name variable, and %d is referencing number variable. You would use %s to represent the variable as string, and %d to represent this one as a float or integer. Let's go back to our dictionary and run our program. So here, the output shows that the dictionary was indeed iterated over, printing phone number of John is this one, and etc. Functions are a convenient way to divide your code into useful blocks, allowing us to order our code, make it more readable, reuse it, and save some time. A block is simply an area of code written in the format where the body is indented. We have seen on previous discussions examples of blocks such as for loop, while loop, and if statements. To define a function, you use the def keyword before your function name. So here, I'm creating a function called my function. Then you terminate it with colon. Since function is a block of code, the body should be indented. We'll add print statement to the body. So hello from a function. Going back to indentation, where in other programming languages the indentation in code is for readability only, for Python it's a requirement, not a matter of style. You'll get an error here if you remove this indentation. So let me try that. So here, when I hover here, let's see. Anyway, it's not showing anything, but it's printing, or it's indicating a red underscore here. So we're having a syntax error here since we did not include any indentation to our body. Okay? You also have to use the same number of spaces. Otherwise, if you do something like this, let me add another print statement. So what's up? Here you can see that it's indicating a syntax error with this red line of code here. It will also throw an error if the number of spaces inside your body is not the same. It should be uniform. So what I'm gonna do to clear this red line here is to make it the same as the one as above, the spaces I mean. Then we'll just add another print statement here outside our function definition. Let's say beginning of program. Let's add another escape here. And then to call a function, simply use the function name, my function, and then with open and close parentheses. Let's just add another print statement at the end of our program. Let's escape this one. End of program. So here I added these two print statements so that we'll see later how the program flow will be. Now I'm gonna run our program. The first line in our output is the string beginning of program. Notice that the two print statements at the beginning of our program, these two, were not immediately executed. That's because the body of a function is only executed when you call that function. The flow of the program was beginning of a program, so the print statement was executed, this one first. And then when we call our function right here, it will go to the body of our function, which will then execute these two print statements, and then going back to the main body or main block, it will then execute this print statement. Then after that, that's the end of our program. So that's how the flow of our program becomes when we introduce a function. It's not like before wherein it's straightforward, line by line. It will be executed in order. Okay? We can also pass information to our function. We can have our function print something based on what we send to it. We'll have our function here accept two values. So we'll create two parameters, first name and last name. Parameters are just variables you define inside the parentheses of your function. These parameters will then store the value passed into our function. I'm gonna modify our print statement here so that it prints our first name parameter. First name is, and then our first name parameter. And I'll just copy this one. Then we'll edit our print statement here so that it prints the last name parameter. When we call our function, we now have to pass two values. The values we pass into our function call are called arguments. So when I say arguments, take note that I'm referring to a value that will be passed into a function. Going back, your number of arguments should be equal to the number of parameters defined in your function. Otherwise, you'll get an error. Let's try running our program without adding any arguments to our function call right here. And it's throwing an error saying missing two required positional arguments. Basically, it's just saying that the number of arguments that you pass into your function call is not the same as the number of parameters defined in your function. So to remediate this, let's try adding an arguments to our call. So our first name here will be John and second name will be Week. And then let's just add another function call. So I'm gonna copy this and let's just use different arguments. First name will be Kobe and last name will be James. Let's see their output. Our program here started printing beginning of program. So it executed this print statement first. Then it proceeded on doing a function call with these arguments, John, Week. So it executed our print statement here with the arguments John and Week. So it printed out first name is John, last name is Week. And then it went back to our main block and proceeded to do another function call, this time with two different arguments. And then it executed two print statements based on those arguments that we passed. Therefore, printing first name is Kobe, last name is James. And lastly, it went back to our main block and proceeded to execute this print statement, which is end of program. Functions may also return a value to the caller using the keyword return. Let's create our second function, which will return the sum of two numbers passed into it. So let's call our function here sum two numbers, and then this will accept two arguments. Then we'll return the sum of those two parameters. We can then call this function in our main block and use it in our print statement. Let's print sum of two numbers is, and then our function called here, sum two numbers, will pass 5 and 3 as arguments, and we'll run our program now. Here we got 8, which is the sum of the two arguments we passed to our function. Since this function returns a value, you can use it to assign a value to a variable. Let's create a new variable called result, and then let's call our function from here and let it do the value assignment to this variable. And then on our print statement, we'll substitute this with our result variable. Then let's run this again. Okay, so the result is just the same. That's how function works. It gives us an option to organize our code and reuse them. Sets are the last collection data type left to be discussed in our tutorial. A set is a collection which is unordered and unindexed. To declare a set, you need to enclose the values in curly braces. So let's create a set, and then on our set, we'll have the following items: apple, banana, and cherry. Then let's print our set. Let's run our program. So here it's printing out the three items that we included in our set. Since sets are unordered, the items has no index, making it impossible to access each items in a set by referring to an index. However, you can loop through the set items using a for loop. Let's try doing that. So I'm just gonna remove this, and we'll create our for loop, and then print each item in the set, and we'll run our program. And we're able to iterate over our set here. You can also check if an item is present in the set by using the in keyword. Let's try doing that. So print banana in basket. Here we are checking if the item banana exists in our set. This would return a Boolean value. Let's run our program now. And we got true, since banana belongs to our set. Once a set is created, you cannot change its items, but you can add new items using the add method. Let's try doing that. So, oops. Okay. Basket, and then we'll use the add method. Let's say we want to add avocado in our set, and we'll print our set here, and we'll run our program. Now we got avocado as well in our set. To add multiple items to our set, we can use the update method. Let's try doing that. So I'm just gonna change this one to update, and then I'm gonna erase this, and we'll add 3 items to our set. Orange. So notice that you need to enclose the list of items you plan to add with close brackets, square brackets, I mean. mango, and lastly, let's add grapes or grape. Let's run this one. Now we got 3 additional items. Oops. Right, 3 additional items to our set. So as you can see, it's unordered, right? We first had apple, banana, cherry, but when we print our set, it printed out banana, apple, orange, cherry. It's not really ordered. To remove an item from the set, we can use remove or discard method. Let's try using both for our example. Let's remove this one. And then we'll use remove cherry. And then we'll remove another item using discard method this time. We'll remove banana. And then we'll run our program. Here, we are left with apple after deleting 2 items from our set using remove and discard method. The difference between the 2 methods though is that remove will raise an error if the specified item does not exist, while the discard method will not. Let's see that in action. Let's try removing berry, which does not exist in our set, and we'll run our program. And as expected, it threw an error since berry does not exist in our set. This time, let's use the discard method. Just change this to discard, and we'll see what happens. So it did not throw an error even though we tried to issue discard command or statement, and we tried to remove berry, which is not existing in our set. After discussing all collection types, it's good to have an idea when to use a certain collection type. In general, if you just need an order sequence of items, go for a list. If you just need to know whether or not you've already got a particular value but without ordering, and you don't need to store duplicates, use a set. If you need to associate values with keys so you can look them up efficiently later on, use a dictionary. If you want to give the programmer and the interpreter a hint that the data should not be changed, use a tuple. For this exercise, we'll create a function that can accept a number as an argument and return the factorial of that number. For example, if we pass 4 as an argument, it should return the product of all numbers from 1 to 4. That would be 4 times 3 times 2 times 1, which is 24. If we pass 3 as an argument, it should return the product of all numbers from 1 to 3. That will be 3 times 2 times 1, which is 6. If argument is 0, it should return a value of 1 since a factorial of 0 is 1. Again, try doing the exercise yourself first before proceeding again with this video. To start our program, we'll create a function called factorial, which will accept one parameter, and we'll have an if statement here to check if our parameter is 0. If yes, it should return 1 because the factorial of 0 is 1. Otherwise, it should return n multiplied by factorial of n minus 1. Notice that we are also calling the factorial function but with a different argument. n minus 1. In computer science, when we allow a function to call itself from within its own code, similar to what we're doing here, it's called recursion. In this line, we're using the same function to do the job of computing the factorial of the succeeding numbers. Let me illustrate what happens during a recursion so you can better visualize it. But first, we know that a recursion will have several function calls within itself. So to make it easier for me to refer to each call, I'm going to refer to each with its function name and the argument passed into it. Let's try calling our function from our main block. And let's call factorial. So for example, if we make a call to factorial function with 3 as an argument, I'll just refer to this specific call as factorial 3. If we pass 2 as an argument, I'll refer to this call as factorial 2. Easy enough to follow, right? Now let's go to our illustration. Here on my right side, we'll start with factorial 3 from our main block. Let me just change this. And I'll update our illustration. Inside factorial 3, our n variable here will have a value of 3. So obviously, this if statement is gonna be evaluated as false. Then we're going inside the else statement instead. This will return 3 multiplied by factorial 2 because 3 minus 1 is 2. Factorial 3 is not gonna return any value yet since we need to wait for factorial 2 to complete. Now we'll go inside factorial 2. So I'm updating our illustration. Here, our n variable is 2 again. So it's gonna go inside the else statement again, but this time it's going to call factorial 1. Let's update our illustration to the right. Now we're going inside factorial 1. This function call will also not return any value yet, so it's gonna call factorial 0. Let's update our illustration. Oops. So now that we're in factorial 0, we're finally gonna have a function that will return a value since this if statement here is gonna be evaluated as true, therefore returning a value of 1 without calling itself anymore. So in our illustration here on the right side, it's gonna return 1. With the call to factorial 0 completed, we are going back inside factorial 1. This time, we now have a value that we can multiply with our n variable, which is 1. So 1 times 1 will return 1. Then we're going back inside factorial 2 and return the product of 2 and 1, which is 2. Finally, we're gonna go back inside factorial 3 and we'll return the product of 3 and 2, which is 6. Now it's time to see this program in action. So let's run our program now. And there you go, it printed out 6. You can also use a while loop here, but I want to show you this alternative approach so that when you encounter a similar code containing a recursion, you'll understand it better. Sometimes using recursion will result into lesser lines as opposed to using while loop. Just be careful though on designing your recursion so that you do not go and do infinite calls. There are debates, though, among developers on when to use recursion and loops, and also which of them is faster in terms of application performance. But I won't dig deeper on the subject, at least for now. So, how was your experience doing the exercise yourself? Did you also use while loop in your function? Or were you able to use recursion? Let me know in the comments below. To recap, we've learned how to use for loop to iterate over sequence objects like lists, tuples, or strings. We also learned how to do iterations based on condition statements using while loop. Then we learned how to use dictionary data type to store unique key value pairs. We also learned how to create functions to organize our code and make them reusable. Lastly, we learned another collection type in sets to store unordered and unindexed data.